All right, we're taking a look at chapter 21, number 54 to start. So we're trying to draw this structure here. So when you look at this compound, you need to think, what is this telling me? That's telling me it's a carboxylic acid. So, and this is telling me it's 6 carbons long. So to get there, we think, okay, you can draw the carboxylic acid on the left or right. Let's just start off drawing it over here. Carboxylic acids will always end like that. And then we think hex, so there's got to be 6 carbons. So this is 1, so we still need 2, 3, 4, 5, 6. So C, C, C. And then all of these need to be filled in for H's. So H's go all around there. The next one, that was A. B says, let me go back up here. 2-methylbutanoic acid. So 2-methylbutanoic. So again, oic acid, carboxylic acid. This time the but tells us the parent chain is 4 long. So we need to make sure we have 1, 2, 3, 4. And now we look, what are the substituents? At the 2 position, there's a methyl group. So this is our 1 position, 1 and 2. So we have a methyl group coming off the 2 position. And the rest are filled in with our H's. So again, all those little lines are going to be H's there. And C says 2-ethyl, 3-methyl, so these are just the substituents, and then the parent chain is a pentanoic acid. So a carboxylic acid that's part of a 5 carbon chain. So let's draw the carboxylic acid functional group. And we need 1, 2, 3, 4, 5. Now we look at the substituents. At the 2 position, we have an ethyl group. So that's right here. Ethyl is CH2, CH3. You notice I'm arbitrarily drawing these on the top. You could draw these down this way, CH2, etc. And then at the 3 position, we have a methyl group. So right here, CH3. And again, the rest will be hydrogens where all those lines are. So H, etc. Your next question was number 62, so let's go down there. A. All right, so we're supposed to draw structural formulas for these. A was propyl methenamide. Methenamide. Okay, so for this, again, I'm trying to figure out what the main structure is. It's an amide. So you got to remember what the amide group should look like here. The amide group will always have some carbon, and then it's going to have a nitrogen next to it. Let's put the nitrogen over here. That's our amide group. So methenamide means it's a 1 carbon chain amide, as in this. It's the tiniest one. So if it said propanamide, we'd have 1, 2, 3 over here. But this is methenamide, so it's a 1 carbon chain, so you just have to put an H there. That's our ending to this chain. And then it says propyl. That is the thing that's coming off of the N on this side. So propyl will come off this side. So propyl group is just 3 carbon, 1, 2, 3. All filled with H's. Notice I still need an H on my N here to get if it's 3 bonds. So there's my propyl methenamide. B says butyl. So my girlfriend sends me a million photos. Butyl in a video. Prop. No 8. Okay, so what's going on here? Again, we need to look to this side to figure out what this is. Oh wait, this is an ester. So it's a propanoate. So within that ester chain, there's going to be 5 carbons. So the end, I guess the ester is always going to be a carbon double bond like this. And we need a, actually I'll draw it on this side. A little more room. O, and there's going to be something coming off of here, off of the O. That's what this butyl group is. The propanoate is the side over here. So there's going to be a 3 carbon chain. 1, 2, 3. This is the propanoate portion of it. And then the butyl is a substituent that's coming off of the O over here. So that's just a straight chain butyl group. 1, 2, 3, and 4. All filled with your hydrogens. So hydrogen in all those lines. So there's butyl propanoate. Next one, C says methylhexanamide. Okay. Hexanamide. If we look back up here to propyl methanamide, so remember this is an amide, so we need this kind of chain, and this was just a methanamide, so there's 1 carbon chain involved, and this is the thing that comes off the N. So we'll think about that in the same way, and I'm going to draw it the opposite direction just to show you. This way I arbitrarily drew the N group on the right hand side. Let's draw it on the left hand side this time. So hexanamide. Here's the N. That means I have to have some substituent coming off there. The hex goes on the other side. So this is going to be 1, hex is 6. 1, 2, 3, 4, 5, 6. All of these are hydrogens all the way around. And then this methyl group is a substituent that's coming off of the N. So I'll just say, whoops, CH3 over here. And remember, this needs 1 more H. Nitrogen always has 3 bonds to it, plus the lone pair to give it its full octet. Finally, D. We have isopropyl. Okay, isopropyl is not super common. That's a structural isomer of the propyl group. So a straight chain propyl group would look like this. All hydrogens. An isopropyl group is slightly different. Instead of CH3, well, we'll draw it in the structure, so you'll see in a minute. So isopropyl pentanoate. Okay, so this is another ester, and we need to have 5 carbons inside this ester group. This is the group that's coming off of the O. So we'll draw the ester core again. Let's say we put our O over here again. So this is going to be attached to here. The pent is going to be extending this chain. So we have 1, 2, 3, 4, 5. All H's, etc., etc. Now we need to draw an isopropyl group. So what does an isopropyl group look like? Well, think of it like a carbon, like this, and we're going to have H here, CH3, CH3. That's our isopropyl group. So a little bit different than the straight chain group. So isopropyl is our group coming off the side. That might have been the trickiest part there. Otherwise, you've got your pentanoate over there. So the pattern with these becomes figure out what it is, draw that core, and think about what it's telling you. So this is a hexanoic chain. An ester is very similar, but we call it, for example, this would be hexanoate if it had anything coming off this O other than an H. So if, let's say this is a methyl group, it'd be methyl pentanoate, or hexanoate. And then just try to identify where those are. Okay, so I hope that made sense. and scroll through this at your leisure, and I will do one last very slow scroll through to make it easier for you to stop on these if you need to. Looks like I forgot to do number 56. So 56 says condensed structural formulas for the ones in 54. So to condense these, writing from left to right, the carboxylic acid group is always H, let's see, in this case, since I have it flipped it around, HOOC, and then you would just have, let's see, CH2 onward with this chain. So let's see here. Sometimes they condense them like this. There's 4 CH2s here, and then there's a CH3 at the end. That's a common way of doing it. So there's a CH2, 4 of them, and then you end with a CH3 group. So that's one way you can do that, or you could just write this out: CH2, 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 CH3, like that. But this is the more common way of showing those long chains condensed down. Let's see here. B would be same kind of thing. We would have HOOC, and then we have CH3 here in parentheses. That's showing you that this is a substituent. Then you write this CH here, CH, and then keep going, CH2, CH3. Do I have too many here? Let me just double check here. 1, 2, so 1, 2, 3, 4, 5. Got it, just double checking. That would be the condense. Honestly, I am not going to tell you guys to do much of this condensing stuff. This is much more valuable than knowing how to do this. But this is how you would do these. And C, what would be the condensed formula for this be? Again, we've got our HOOC, whoops, for this group. So what's going on here? Well, we can write our propyl group in parentheses first. So we've got a CH2, CH3 group. Make sure you can tell this is a bracket, CH2. Then you want to make sure you write out the CH there. And then similarly to before, now we can just write a CH3 in parentheses to show that it's a substituent. CH3. This one. Then we need another CH, and then CH2, CH3. Kind of convoluted, but this is how we would do this. So it's COOH, then you're going to name off the substituent, and that's attached to this CH. Then you're going to name this substituent and show that it's attached to this CH, and then CH2, CH3. That would be your condense. So I hope that helps. I know we haven't done a lot of practice with these in class, so those were probably pretty tricky, but I'm not going to try to fool you guys on the exam. All right, I hope that helps you figure out those condensed structural formulas as well.